Good morning. Welcome to S4GA webinar. It's a big pleasure for me today to host this webinar for all of you. I believe that some of people who join us today, I know personally, we met at different occasions at trade fairs or at face-to-face meetings. So I welcome you, and I also welcome new people who decided to spend their 1 hour of their lives listening to this information that we are going to provide. My name is Dmitro. I work in S4GA as Business Development Manager. I represent S4GA, and we are manufacturer and supplier of world's safest runway lighting. Why do we do today's webinar, and what is the topic? First of all, the reason for webinar is because we've been asked this question so many times, so we decided to spend an hour and really get into details of the power supply of S4GA solar runway lights. The number one question is its availability. This is what normally bothers consultants, airports, contractors. They all ask the same question. So if solar lighting availability is 100%, and I will spend next hour trying to explain how can S4GA runway lights operate 365 days on solar energy only. During the presentation, I will make breaks so you guys can ask me questions using chat. Please do not unmute yourself. Simply use your chats, but so I will allow all of you ask questions that are not answered by myself. So agenda. Quickly, I'll tell you about, again, who we are, what we do. I will remind you what airports S4GA solar lighting is designed for and who is using it and why. Of course, I will present you with few examples of airports that are using permanent solar runway lighting today. And then we will get to the three key fundamental points that we want you to understand. Power supply, 365 days availability, and how do we assess probability of complete battery discharge, because we don't want this to happen. During my presentation, I will switch on a couple videos, and some of videos will have audio. So you will hear me from the recorded materials. Please don't be surprised. All right, so let's start. As I said, S4GA main focus is to deliver world's safest runway lighting. And when I say world's safest, I mean the probability of complete lighting outage in our systems is close to zero, and it is also significantly, and I mean significantly lower than in case of conventional, traditional lighting systems. The company I represent is government-owned, and all our lighting units are certified in accordance with ICAO Annex 14. Today, over 50 airports are using our systems in more than 30 countries in the world. So which airport is S4GA solar lighting is for? We have two segments. The regional airports that are operating non-precision approach. They are using S4GA permanent runway lighting instead of conventional. international airports that are equipped with Cat 1, 2, 3 systems, they use our lights as contingency or emergency. Very often, when international airport that is operating 2 or more runways is sometimes preparing itself for the worst case scenario. So what they do, they equip one of their runways that is not frequently used with solar powered lighting and keep it on standby. So in case of emergency, they can always switch over to this runway. Few examples. It's just few examples of the airports that are using S4GA permanent runway lighting. They have no other source of power other than solar, and then they are using these lights every day, 24/7, 365 days a year. Ethiopia, it's a Jigjiga airport. This is a regional airport in Ethiopia. They illuminate its 2.5 meter runway with S4GA solar lights because of two main reasons. First of all, there is no main power supply available in the region, so utility is unavailable. So even if they would have installed wire runway lighting, they would have to pay huge electricity bills annually because electricity in Africa is one of the most expensive, and also it's not really reliable. So Ethiopian Airlines decided to equip this entire airport with solar runway lighting. Maldivian airport. This is one of the islets on Maldives, a regional airport that is they're servicing 5 flights a day, ATR 72, and they use S4GA lights as a permanent solution. There is no electrical supply other than diesel generator, which is expensive and basically not very green. And there's no experienced engineers available. Europe, it's an airport in Lithuania. It's a domestic airport. They also use this system as a permanent. They had no budget for wired AGL, so they decided to install solar. And they also was looking for a certified system. So again, all these 3 airports operate 365 days on solar energy only. There is no backup power, there is no cables, it's not a hybrid system. So now let's get to the fundamental topics that we want to cover. Number 1 is the power supply. Now I want to explain you how our power supply works, but before I will do it, I will want to remind you about power supply issues of traditional hardwired runway lighting that you all know. So the main and the critical problem of every traditional runway lighting system is that it has centralized power source. So there is normally one utility power source, one backup generator. To you who would say that no, there are normally few generators or UPSs on the airports, I would remind that we are talking about regional airports that are operating one runway, 1.82 kilometers, and they have no budget for all this kind of backup equipment that are available for big international airports. We are not talking about well-funded airports. We are talking about regional airports that has low budgets, so they have to keep capex as low as possible. So as I said, the power source is centralized, and traditional runway lighting consists of few key elements. You have mains power supply, you have substation, backup power network, and control system, right? Even though all these elements are reliable, But as a combination, because they are all interconnected, failure of one or few elements can lead to the failure of entire system. So as I said, in case of utility break, you can say that light will be switched to the generator, but it's not always the case, because generators in those countries where we supply our airfield lighting, so Asia, Latin America, or Africa, generators are not always ready and not always well maintained. So they might fail you as well. On the contrary, S4GA solar runway lighting is designed with a different kind of philosophy. First of all, you have, sorry, hold on, I need to mute the participants. So the mentality is different, and the philosophy of design is different. Every light has two power sources, main and backup. What I mean by two, I mean that every light is equipped with two batteries, and battery one acts as a main power source, and battery two it remains backup. In case of failure of battery number one, the second one will keep light operating. So the system operates on solar energy only, and solar energy is available every day, and it's more reliable than an electrical energy because it cannot fail you. And because lights are not interconnected in any way, then fail of one light does not influence entire system. So you can lose 1, 2, 3, 5 lights, but still all your system remain operative. Unlike in conventional lighting, if you use substation, or you cut the circuit, or you lose the power supply, you will definitely lose either major part of lights or entire lighting. Next critical topic for us is, well, how can we make sure that S4GA system will perform in different location and it can perform 365 days on solar energy? To answer that question, you need to understand two things. Number one, each light every month consumes around 900 watt of energy. How do we calculate it? Well, assuming that light will work 12 hours a day, and let me remind you that on non-precision airports, lights are not used 24/7. They are rather used maybe 3-4 hours a day because there is the traffic there after sunset is limited. So we assume that lights or the light will be active for the whole night, so 12 hours. It will consume 30 watt energy a day. So 30 watt times 30 days gives 900 watt of a power consumption per month. There is a graph here. Hold on, let me just show you something. So there is a graph here that represent energy consumption on this axis and months is on this axis. So the energy consumption is calculated in watts. And the graph of energy consumption is very simple. Well, our light requires 900 watt of energy to operate every month, 12 hours a day, right? The next question is, can the solar panel of the light, can it provide sufficient amount of energy to cover the energy consumption? Which means the power balance will be positive. And to check it, we have to simulate it using a system that is called photovoltaic geographical information system. So now I will activate the short 5 minutes movie about it, and it's recorded. You shall hear sound of the movie in right now.
Photovoltaic geographical information system is an effective tool that has been developed by European Commission. PVGIS provides an open PV performance assessment tool. It covers any location in Europe and Africa, as well as large part of Asia and America. This system allows S4GA to simulate monthly energy production by S4GA light in a particular part of the world. The question we answer is whether power generated by solar panel will cover energy consumed by the light. As an example, I will demonstrate 3 simulations provided for Norway, South Africa, and India. All these countries have very different solar energy potential, but it is important for us to understand if S4GA system can operate in all 3 of them. So let's start. First, we need to select a location. Pretoria in South Africa is selected. 0.02 kilowatt translates into 20 watt, which is power output of S4GA solar panel. System loss is 14%, which is a standard figure. Standard slope of S4GA solar panel is 33 degrees. Azimuth, which is orientation of solar panel, that is optimal for Pretoria, is -179 degrees. Slope is an angle of PV module from the horizontal plane, and azimuth is the orientation of the solar panel. Let's now press Visualize Results. Now you see how much energy S4GA light produces every month during a year. If it is installed in South Africa, for example, in March, it will generate 2.7 kilowatt of energy. In September, 3.22 kilowatts of energy. These calculations were for South Africa. Let's choose another location where we have less sun. For example, Norway. As you can see, in winter, solar panels will generate comparatively small amount of energy, only 0.62 kilowatts in February. However, in summer, it will be 2.65 kilowatts of energy. So the difference between winter season in Europe and summer season is significant. Let's now check the third location, Asia. We choose India, for example. why did we choose Delhi? It's because we know that due to the high density of dust in the air, there are certain concerns whether solar system in Delhi will be efficient. But this system clearly answers that question. So for Delhi, as you can see, average generation of power along the year is almost the same. System can generate on average around 2.5, 2.6 kilowatts of energy per month. So what do all these results mean for us? It means that in regions where we usually install our lights, in our examples it was Africa and Asia, photovoltaic potential is very high. Single S4GA light generates on average 2.5 thousand watt of energy monthly. Power consumption of the light operating every day for 12 hours is 30 watt a day. That translates into 900 watt per month. So if you want to compare power that is generated to the power that is consumed, if we draw the line, then we need around this amount of power to feed the light every day for 12 hours. But the amount of energy we have is significantly higher than what we need, which means that we can maintain positive energy balance throughout the year, which enables the system to operate 365 days a year on solar energy only.
So, what have you learned? Just to sum it up. For South Africa or India or Maldives, basically for entire Africa and Asia, we have very positive energy balance when energy that we can generate is almost always much higher than what we need to power the light every day. So that is why S4GA light in this location can work 365 days without any interruptions. Because power that is consumed is 900 watts on average every month, and the monthly generation is 2.5. So we have actually 2.5 times more energy than we need, and we are losing much of it. Another question that is raised is, all right, then let's say you have a per month, we can see that your light using less energy than it produces. But what if there is a 5 consecutive days of 4 or 14 consecutive days of no sun or cloudy weather? How can you make sure that your light will not, approach complete discharge? So we are doing second test where we confirm that where we assess actually is the probability of complete battery discharge. And again, we are looking at every time we are looking at the single light. We do not look at the runway lighting system of 100 lights or 200 lights. For us, it doesn't matter. Because if single light can operate 365 days, no interruption, then entire system will. So it's not like we do not look at the performance of the system, because every light is not connected. Every light is independent. If every light can work, all system will work. That's the philosophy. So now, again, let me show you how we assess these everyday operations and make sure that there is going to be no day when the battery will reach complete discharge. First of all, you have to understand that the battery in the light holds capacity for 180 hours, right? So if you have 180 hours and you use the light for 12 hours every day, you can quickly calculate that even without sun, the light will work for, well, at least 10 days easily. Now I'm going to show you the quick movie.
To perform second test of 365 days performance, we are using a tool that is called Performance of Off-Grid PV Systems. Using this tool, we will calculate how many days in a month our light will be fully charged and how many days in months our light will be completely discharged, which means that lights will not be able to operate. Let's check it for 3 locations: for South Africa, for Norway, and for India. Let's start from South Africa. So let's select a location, Pretoria. Now we need to fill in necessary data about S4GA light. Installed peak power, which is power output of S4GA solar panel, is 20 watt. Battery capacity of single S4GA light is 216 watt. Discharge cutoff limit is 30%. Daily consumption of the light that operates 12 hours a day and is on standby for 12 hours, so light is switched on for 12 hours, is 30 watts per day. Slope of the solar panel is 33 degrees. Orientation is -179. Let's go to performance. Now you see the graph which shows how many days per month the batteries will be full and how many days per month the batteries will be empty. As you can see, in South Africa, we have no risk that battery will reach zero level. Now let's check Norway. As you can see, from October to February, the percentage of days when battery is empty is going from 35 up to 100%. During nice summer period, the percentage of the days when battery is empty is insignificant. So it means that lights will be able to operate there for the whole month without any interruptions. Finally, we check results for India. So let's select the location. For Delhi. As you can see in India, and the same we saw for South Africa, S4GA airfield lights will operate 365 days. Batteries will be fully charged for 99% of the time.
Okay, so I think that the video is finished. I have tried to answer also a couple questions as we were speaking. So sorry for all the typing. Now, to sum up what you have seen. You have seen that the assessment process that S4GA system undergoes in order to ensure that even if there is some consecutive days when we have bad weather, no sun, cloudy, that the battery will still remain charged and light will remain operational. Because light has such a huge capacity comparing to consumption, there is no risk of light getting completely discharged. And when I say no risk, I mean there is no risk in these areas where we usually install our lights. But even if you install the light in Norway, where one would say, well, Norway, solar, it will not work. It's not true. Because in Norway, you have months from April till November, light will work perfectly. It is just those winter months when those lights would require additional charging. So if in Norway it will work, for sure it will work in Libya or South Africa or India. Okay. Another question that we are frequently asked, sorry, hold on, is, well, what happened? Will your light work during the fog or heavy rain or, strong winds? Because people think, well, there is a fog, there is no sun, light is solar powered, what will happen? Or there is a dirt, there is a sand, so what will happen? The answer is like that. Will our light work? Yes, it will work, it will operate, because it does not require sun every day. The question is, will airport operate in such weather conditions? If we talk about non-precision airports, this is no-go. If we talk about any other airports, this is no-go. This probably will be questionable, because if you have too much sand and dirt in the air, then it might disrupt airlines from flying. So that would be the answer to this kind of questions. So to sum up, S4GA solar runway lighting is a power safe system. Why? Because it does not rely on any utility power supply. It does not require a generator. It does not require any cable. So if you want to kill the system, entire system of S4GA lights, there is really no single point you can attack to stop it operating. You have to stop and kill each and every individual light. It operates 365 days on solar energy. How we assess it? We use simulation tool, clearly states and clearly proves that because we use 20-watt solar panel, because it is specifically designed this way, so it's installed outside of the lighting body, entire solar panel is facing one direction and it is tilted, it generates significantly more energy than light requires. When I say significantly, it means we can generate 2 to 3 times more energy than light requires. And this is why S4GA solar runway lights is a perfect permanent solution for regional airports and also for international airports as a contingency runway lighting that can be on standby. Thank you very much. If you have questions, I will be happy to reply now. if each light consumes 900 watt. No, it is only the most power consuming light that we are talking about is runway H and approach lights. Why we say 900? Because if runway light consuming 900 watt will work, then any other type of light that consumes less will work as well. Also, there was a question about the design of solar panel that is attached to the light. So the main concern is, will it can it be disrupted with a jet blast? We have performed jet blast resistance test in a special wind tunnel. You can look at the movie at our YouTube channel, and our light can withstand wind power of 240 kilometers per hour. What else? The next question is if our lights can be controlled through the, I understand this is airfield lighting control and monitoring system. Yes. Yes, they can be controlled. S4GA actually is, I can show you if it's possible right now. Let me just activate my screen. LCMS, okay. Hold on. Maybe let me show you my screen, how it looks. This part is, I think, is the one that really amazes the airports when we show it. It's our airfield lighting control and monitoring system. This one that I will be showing to you is a demo, of course. It's a simple version of what we can provide. So basically, you have two panels. You have control and you have monitoring. And control, well, you can say, yeah, it's a basic function, although it is made in a clear way. But what really interests you is a monitoring feature, because we can individually monitor every light in case if the light has some problem issue, it will become blinking red. You can actually click on it. Now I'm clicking it, and I can see what has happened. In this case, for example, we see that the connection with the light was lost, even though the battery was 94%, which means that the light might be mechanically damaged, or the radio is off. So there is no connection between the control system and the light. The yellow means that there is not critical warning, but it is a warning, so our technician shall have a look. In this case, for example, battery is 15%, so it's low. It might mean that the battery is damaged or not, does not hold the charge, so it has to be exchanged. And here is perfectly working light where status is normal, battery level is 99%, solar charging is okay, and so on and so forth. Yeah, so that's how it looks. Okay, certificates available for installing approach lights on frangible mass. What is the weight of 2 batteries approach fixture? The weight of the light is 12 kilograms. If it can be integrated to existing control system, it can be integrated. The photovoltaic geographical system is free to use. We can share with you. It's actually, I can show you. Everyone can approach it. If you put PEP-GIS, and then, well, here is a website. I can share it. No problem. Here, hold on. Sorry, let me just share with everyone. This is a link to the photovoltaic system. So here I can, sometimes it's slowly downloading, but basically here we can enter it and perform all the testing independently of S4GA. So you don't need us, you just need the parameters. You need to know where you are and parameters of our lights. Here is the system. There is no password. You can easily approach it and make all the testing according to the video that we just shared. Okay. You said there are two batteries, so when battery low, alarm is on. Does it mean both batteries are low? No. Yes, it means that both batteries are low. The standby battery will be triggered in case of a failure of the main battery. But the light alarm actually it monitors both batteries together. What about values and calculation of the slope and azimuth? Okay, it is not a problem. Hold on. Slope is always the same. So you use 33 degrees because it's a slope that for the S4GA solar panel. And azimuth, for azimuth you just have to the system shows you. This system can help you. I mean, this website can help you to optimize the azimuth. Let me show you how it's done. For example, I choose some location. Then if I put here optimize slope and azimuth and click visualize results, here, because I chosen optimized azimuth, it already tells me that it's -3. So what I can do, I can put here -3 plus 33 degrees, and it will be calculation done for the S4GA light. Okay, which technique is used for the CNM communication, control and monitoring? We are communicating with the lights wirelessly, means each light is equipped with a wireless transceiver. It's a mesh network protocol, and it uses 868 megahertz frequency that is encrypted, and the power output is below 16 milliwatt, 16 milliwatt, which means there is no risk of any problems with existing nav aids on the airport, no interference. Now another question. Well, generally the major problem in the PV world is conservation of energy. My question is, which is battery life of your system as well? How to extend life of batteries in terms of extending life, operation, and system health? You are right. The conservation of energy is an issue, but it's the same type of issue as you have with the fact that when you using the car, the parts of the car are being used, right? So we say like this. First of all, battery life is two years. 2 years, 3 years in Europe, 2 years in a hotter location, and in super hot location might be 1.5 years. But the thing is that you have to treat the battery as an oil in your car. So you have to exchange it. You have to take care of it. You cannot just assume it's maintenance free. There is no maintenance free battery exists, which means that every couple of years you have to perform maintenance action. You have to open the light, take out 2 batteries, and put 2 new ones. The good thing is that if you had 100 lights on the system, then the cost of 1 battery, for example, here in Poland is $20. So you have $40 per light times 100. You have $4,000 of maintenance cost every 2 years, which is insignificant comparing to the conventional, which is insignificant comparing to the cost of electricity you would use in case of a conventional lighting. In order to extend life, you have to keep batteries as charged as possible, but because the system is solar powered, solars will recharge battery to the fullest as soon as possible, so you don't have to worry about that. A fixture including communication model CE approved. Yes, of course. The communication model is CE approved and the fixture is CE approved. I confirm. Have I missed any of the comments? Is in scenario where we have parallel runways, how is your solution in communication system of different runway? Okay. The best way to show is to maybe, hold on. Let me show you the LCMS system. Okay, for example, let's assume you have runway number one on the top, and yeah, and you have runway number two here. The thing is that because each of our light is addressable, we group them. So for example, for this, we can group them as we like, and we do not require any CCRs, right? So we can create as many groups as possible. So controller can simply send the signal when you activate runway. You only activate the lights on the runway. When you activate taxiway lights, you activate taxi level. Just to show you the example, we can create as many groups as possible. Now I'm switching on and off the taxiway Alpha, now Bravo, Charlie, Delta. And we can do 100 groups, 1,000 groups. We can do as many groups as we have flights in the system. I hope this was your question. In case if you think of something else, first of all, this webinar will be available on YouTube in a couple of days. The second, here is my email. If you need to communicate and ask and clarify something, you are welcome to do that. Sorry, again, I'm sending the private. Yeah, here's my email. Now, if you have any questions about batteries or communication protocol or control or LCMS, you're welcome to basically communicate with me. Another question. Johnny Bravo asks, other suppliers use batteries that you can replace every 6-7 years. Why S4GA every 2 years? Well, who are those suppliers who can offer you 6-7 years? Because I don't believe that it is possible. Karmanach 6 years battery is not true. We are using the same batteries, and sometimes they're using cyclone batteries that they combine into power packs. In this case, the battery that they are using can survive maybe a little bit longer, 4 or 5 years, but not 6-7 years, and specifically not in hot locations where they are sometimes found. And the reason why we decided not to go to this kind of battery is very simple. I'll give you an example. Let me just activate Excel file here. I'm not sure if you can see my Excel, but let me check. Yeah, you can see my screen. Okay. Now. Yeah, so that's the screen, right? So let's assume you have 100 lights. Yeah, you have 100 lights in the system, and you have battery per light. You have 2 batteries in our case, right? And they work for 2 years, as we state. We need 200 batteries to exchange every 2 years. The cost of one battery, $20. If you multiply 200 by 20, you have 4,000. So your annual maintenance cost is 4,000 by 2, $2,000. Now, the batteries that Karmanach uses is a cyclone battery. It's a specially designed power pack. The cost of it, depending on the country, and this is what I hear from one of the Karmanach distributors in United Arab Emirates, cost $1,200 as a spare part. So now, if you want to exchange 100 lights, you need to pay $120,000, which means, let's say they work 6 years, right? So what would you rather do? Have battery that you will have to exchange every 2 years and pay $2,000 a year, or $20,000 a year? That's your call. And also, our battery in S4GA lights are standard. You can buy them on Maldives, Sri Lanka, South Africa, and you can order them without our permission or approval. In case of Karmanagh, if your battery dies, you call Karmanagh, you have to order from them. If they change prices, you are hostage. But they use very good batteries. However, they are not as good as it is stated. The second thing, they are expensive. The third thing, you have no flexibility. So that's why. Okay, now, Malek, what action must operator do when low battery alarm is on? At what level action must be taken? All right, well, there are 2 levels of that. Number 1 level is to keep runway lighting operative, right? To land airplane. If there is only 1 battery low, it's no problem. You can lose the light, nobody will even notice. But the thing is that what you have to look at is that when you have all other batteries levels are 100 and only 1 light is 20, then it means something is wrong with the battery. So battery cannot hold the charge. And this is what you're using it for. In case of 20% of the battery, I would simply take the light off. I would check if the battery is okay. If it is, maybe the solar was not connected. And also, you can always use the charger. So you can connect this light to the charger in the hangar. 6-7 hours, it's fully charged, and you can get it back on the runway. My last question. Some airports, authorities, especially uncontrolled airports, they require to have PALC. Do you have any this system in your products? Yes, we do. We call it PTT or VHF activation. So the light is, it's not the light, but there is a controlling unit that can receive signal from the pilot radio, and on 3, 5, or 7 clicks, it can activate the light. So there is no need for ground personnel to be available. To answer your question, yes, we do have pilot activated light control as well. On top of that, we do have GSM activation, and we do have GSM monitoring, which means that for such airports, uncontrolled ones, right, where you have solar lights, where you don't know what's happening to them, and you have to send the airplane there, the good thing would be to find out what's happening with the lights. So we have so-called automatic alarm messaging, which means that when battery is low in any of the lights, or light is unavailable, SMS will be sent automatically to the predefined personnel, so you can make an informed decision whether to fly there or not to fly there, but you will be informed about that. Thank you, India Aviation. I have seen your question. So maximum and minimum temperature in S4GA fitting can operate. The maximum and minimum in the temperature is defined by the battery. All the parts except for the battery have wider range, but the battery is certified from -20 till +50. In case if you need deeper, so you have to go to -30, -40, or you have to go to +80, it is possible to do. We just have to exchange the battery for the special one, which will cost 4 or 5 times more. But we do that sometimes when Army of Scandinavia, for example, they they want this kind of temperatures. Or you have a air base in Afghanistan, right? So there you need -40, -30 degrees. Another question that you might want to ask is, why do other suppliers of solar lighting have panels that are built in, right? And we have panel that is installed outside of the light. So when the panel is installed outside of the light, this is the only way to collect maximum amount of energy. When the panels are built into the walls, they are not very effective. So they can provide you with 20–30% of what our panel provides, even though the power output of the panels is the same. What is FOD? What does it mean? Johnny Bravo is asking if panel is FOD. I think we need to hold on. Let me show you something. Let me show you one movie, because I think this is important for the design of the solar panels. Okay, how can we keep the battery life in case of storage? In case of storage, is the panel okay? First, let me show you the short movie. It's 3 minutes only, about the jet blast resistance. You can ask all other manufacturers that you know, including ADB, OCHEM, Karmanach, if they can provide you with such test report on a jet blast resistance, right? So here it is. Let me just share the screen with you. It's going to be a movie, 3 minutes only. Please take a look.
S4GA solar runway lights are installed on regional airports and military air bases. It is important to make sure that lights are capable of withstanding jet blast and extreme wind load from every direction. S4GA equipment has to undergo multiple tests in order to ensure highest redundancy and exclude probability of failure. Among other procedures, S4GA lights are tested to confirm jet blast resistance.
We are at Warsaw Institute of Aviation. The institute owns Laboratory of Aerodynamics, one of the biggest aviation research and development centers in Europe. Today, we will test jet blast resistance of S4GA airfield lights. Jet blast test is designed to analyze the ability of airfield lights to withstand jet blast, propeller wash, and surface wind gusts. ICAO requirements for maximum wind speed resistance of 240 km/h for our type of airfield lighting. Here today, we are going to confirm the compliance of S4GA.
S4GA lighting unit is prepared for testing. It is mounted on a special platform which will rotate, allowing to test jet blast resistance from every direction. Test is being conducted. Wind speed is slowly increased to reach 240 km/h. Laboratory expert is constantly observing the light. Light has accomplished several revolutions, being blown over by air flowing at 240 km/h. Testing procedure has been completed. S4GA light has successfully passed the jet blast test.
We are truly happy to see that S4GA fittings tested today have successfully passed jet blast test. All models that have been tested and can withstand the wind speed of 240 km/h, which makes them the safest to use on commercial and military airports. When designing our products, we always think about safety. We use high-quality materials and innovative technologies to make our lights as reliable as possible. Testing is obligatory part of manufacture. Today's jet blast resistant test proves, once again, S4GA commitment to safety.
Okay, now I'm back because I was talking, I forgot to activate my mic. Hold on. Now, a few more questions I see here. I think that this movie answered the question about jet blast and if the panel or the light can create any sort of damage for the airplane in case of the start or landing. It's not. And S4GA is the only manufacturer that performed such jet blast test in a wind tunnel. How can we, another question, how can we keep the battery life in case of storage? Well, you just have to disconnect, deactivate the battery inside of the light. And it can be stored for up to 6-7 months, no problem. If it is kept disconnected, you have to charge it every 3 to 6 months, and it's gonna be healthy. Is it good to keep it connected to the charging station? It's the best solution actually, because charging station will not damage the light. The light is protected against overcharge, so it will simply will life of the battery longer. Another question, sometimes the weather is bad and lasts for 2 days or more. How will the battery status be in this mode? To be honest, I do not understand the question. If the battery is bad and lasts for 2 days, doesn't matter for the light. It really depends on how much energy you will use. You have 180 hours. So even if you use light for 12 hours every day, you would use 24 hours of 180, which is 10%. Another question, PAPI also tested in this way, large volume. PAPI is not tested against jet blast because PAPI is installed on the outside of the runway, so there is no jet blast. There is no jet blast risk on the PAPI. Any other questions? And I really welcome challenging ones. Like if something bothers you or something does not sum up, or you believe something is not covered, that's the moment. In case if anyone would be visiting air traffic management in Madrid in March, you are welcome to schedule meeting. One of our salesperson will be visiting it too, so it's a good opportunity to meet. Yeah, Mario, thank you for the question. The question is why the communication range is only 1.5 kilometer is enough. Oh, it's a very good question actually. Let me answer it. It's not really about hold on, solar power, but I will answer it, no problem. So this my screen is shared, you see it. Okay, so now let's assume, right, that we have a runway of 2 kilometers. So this is 2 kilometers. This is, let's say, I don't know, 600 meters here, 2000 meters here, right? So that 1.5 kilometer will be somewhere here. I'm not a mathematician, but let's say this is 1.500 meters. So the thing is that how our radio operates. the control unit sends the signal to all the lights it see. So let's say this is a radius of 1.5. So everything outside of the radius of the control system. The question is, how will the signal reach there? So because it's a mesh network, the signal will jump from light to light. And so each light is a transmitter and receiver. So the signal will be retransmitted to all the lights, even though they might not be visible by the control unit. This is how it can, this is why we don't need 1.5. There are another manufacturers that are using point to multi-point protocol, and they have 4 kilometer range. But the thing is that point to multi-point protocol means that you need to, the control unit has to connect to every single light. If some light has no reach, it will not activate because the signal will not be retransmitted. And we are using mesh network where signal is retransmitted from light to light. Okay. Can you operate 24/7? Yes, we can operate 24/7. What is hybrid system? Hybrid system is the system where we have 2 power sources. We have solar panel connected to the lights, and we can add simple 230 volt system that we can connect to each light. So each light would have 2 power sources, solar and 230. This means hybrid system. But rarely customers want to do that because of the cost and because solar is in 99% case it is absolutely sufficient source of power. And any system that would involve cabling, so because to provide 230 you need to lay cables. It means that, well, you have to maintain them. You have to make sure that they are well secured, because if they are not, they will start corroding and then system will break down. Okay. If there is no more questions, I really thank you, all of you. And it was a pleasure, even though I did not hear you or I did not see you. I knew you were there because you asked very good questions. I really appreciate it. It helped me. I hope that you enjoyed this 1 hour spent. And I hope we can hear each other, see each other in your countries while we travel or during the trade fairs. Again, pleasure, and looking forward to meet with you in person someday. If possible, and if you have any comments on how we run the webinar, and if you think we can do it better, it would be great for you to share with us. We will always try to make it better next time. Thank you very much. Bye-bye.